When we study sets, there is a very important component of the vocabulary because you learn a few words that are very useful as you try to solve problems. So I made here a list of some vocabulary for sets. So first of all, the sets are represented using curly brackets, right? And inside we put numbers. So in the first vocabulary word would be the universal set, which is represented by U, no big deal. But also we have operations with sets, union, which is again like a U. Then we have, which means put together all the numbers. If you have union between 2 or 3 or 4 sets, put together all the terms, but again, of course, written only once. Intersection is represented by union turned upside down, and it's the common numbers. A prime, it's the complement of A, which means what it is in the universal set, and it's not in A. This E means belongs to. So a point belongs to a set. Or it does not belong. A number belongs to a set or it doesn't belong. This sign here, a tilted U, means included. So if we have two sets A included in B, means every element of A, it's also in B. So one interesting problem is when you have this set X with the property that X is all bears, and the question is this set included in the set X with the property that X is all white bears? So is this set included or not in this set? Are all the bears white bears? No. So the first set is not included in the second set. But at the same time, we can say that X, with the property that X is all white bears, it is included in the set X with the property that X is all bears, right? So all the white bears are elements in a set that contains all the bears, the white, the brown, and so on. So let's solve one problem. Let's say we have given the universal set to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Sometimes we can also write this as U equals 1, 2, 3, and dot, 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 and 11, and that means all the numbers. But because if you have terms up to 100, you don't want to spend too much time writing just the terms. So the universal set is given. A is the set formed by 1, 2, 3, 7. B is by 1, 4, 8. And C is 1, 2, 5, 9. And we want to find the complement of A intersected with B, union the complement of A intersected with the complement of C. So in the vocabulary, we said that the complement is what it is in U and is not in A. So basically, let's find the complement of A. So A prime is what is in U and is not in A. So A is 1, 2, 3, and 7. So all the rest are in the complement. So 4, 5, 6, 8, 9, 10, and 11. Because basically A with its complement should equal, union with the complement should be U. Now B, we have whatever we have for B, so I just copy it. And I can immediately calculate the intersection of A prime with B, which is intersection, right? This sign, and intersection means where they intersect, what they have in common. So what they have in common is 4 and 8. So 4 and 8. Let's do the same thing with the other set. A prime, we already found it. It's 4, 5, 6, 8, 9, 10, and 11. and C prime is the complement of C. So basically, I'm going to use a different color. So I have 1, 2, 5, 9. So 1, 2, 5, and 9. So all the other ones that are not underlined with green are in the complement. So 3, 4, 6, 7, 8, 10, and 11. So what we have to do for our problem is to find the intersection of the complement of A and C. So intersection, again, it means common. So what do they have? What common terms? 4 from here is common. 6, it's common. 8, it's in both. And 10, it's in both. And 11, it's in both. So now I'm going to copy what I highlighted in yellow, but only one time. So it's 4, 6, 8, 10, and 11. But the problem that we had to do was to find the union of these two sets that we found here. So 4, 8 union with 4, 6, 8, 10, and 11 means put everything together, but of course written once. So I have 4, 4, I'm just going to put just 4, and then 6, and 8, and 10, and 11. This is the answer to this problem. I hope it helps.